6 Polynomials, subtopic 6.3 Partial Fractions. At the end of the lesson, students should be able to construct partial fraction decomposition when the denominators is in the form of, first, a linear factor, second, a repeated linear factor. So if you can see here, a linear factor which is repeated twice, and third, a quadratic factor that cannot be factorized. Next, we have to change rational polynomials to proper fractions when the degree of the numerator is the same or more than the denominator, and then determine the partial fractions. So if you look at the diagram, we have two types of fractions. The first one is proper fraction, and the second one is improper fraction. So if you look at the proper fraction, definition of proper fraction, when the degree of the numerator is less than the degree in the denominator. So what is the degree? If we can still remember, degree is highest power of x. Okay, so if you look at the example, 2x squared minus 7 over x cubed plus 1. In the numerator, the degree is 2, while in the denominator, the degree is 3. So degree in the numerator is less than the degree in the denominator. So 2x squared minus 7 over x cubed plus 1 is a proper fraction. So for 3, we have 3 times x power 0. So the degree is 0. And while in the denominator, the degree is 1. So the degree in numerator is less than the degree in the denominator. So this is a proper fraction. Third example, x squared. So the degree is 2 over x cubed plus 1. So the degree is 3. Degree in the numerator is less than the degree in the denominator. So this is also a proper fraction. And in the last example, we have 2x squared minus 7. So the degree is 2. X cubed plus 1. The degree is 3, and the degree in the numerator is less than the degree in the denominator. So this is also a proper fraction. Next, we're going to look at the definition of improper fraction. So what is improper fraction? When degree of the numerator is greater than or equal to the degree of the denominator. So if you look at the example, so 2x power 4, degree is 4. Over x cubed plus 1, the degree is 3. If you can see here, the degree in the numerator is higher than the degree in the denominator. So this is an improper fraction. In the second example, we have 3x cubed plus 7, so the degree is 3. Over 2x cubed plus 5, so the degree is also 3. If you can see here, the degree in the numerator is equal to the degree in the denominator. So this is also an improper fraction. If we look at the first example for repeated linear factors, in the numerator, we have 2x plus 1. So 2x plus 1 is a linear. But x minus 3 squared is a repeated linear factor. Okay, so for linear factor, if we express the fraction into partial fraction, into general partial fraction, so for linear factor, we're going to have a constant over the linear factor. But for repeated linear factor, so if you look here, the linear is repeated twice. So for the first fraction, we're going to have a constant over the linear. And we have to, the second fraction is, we're going to have another constant over the linear which is repeated twice. Okay, if you look at the second example, we have x squared times x minus 7. So x squared is not a quadratic. It is considered to be a repeated linear factor. We repeat x twice. So this is repeated linear factor, while x minus 7 is a linear factor. So if we express 2 minus 3x over x squared times x minus 7, we're going to express it as a constant a over x plus b over x squared. This is for the case of repeated linear factor, plus for the linear factor c over x minus 7.
Example 13 on page 15. Express 15 plus 34x minus x squared over 3x plus 1 times x minus 1 squared in partial fractions. So this fraction is a proper fraction since the degree of numerator is 2 while the degree of denominator is 3. Since the degree of the numerator is less than the degree in the denominator, so this is a proper fraction. So let's have a look at the factors in the denominator. 3x plus 1 is a linear factor, while x minus 1 squared is not a quadratic factor, but it is a linear which is repeated twice. Hence, it is a repeated linear factor. So first, we have to express the fraction in general partial fractions. So when we express the fraction in general partial fractions, for the linear factor, we're going to have a constant a in the numerator. And for the repeated linear factor, we're going to have plus b over the linear factor plus a constant c over the linear factor which is repeated twice. Next, we have to equalize the denominator. So we're going to have a times x minus 1 squared plus b times with 3x plus 1 times x minus 1 plus c times with 3x plus 1 over 3x plus 1 times x minus 1 squared. Next, we have to compare the numerator. So we're going to have 15 plus 34x minus x squared equal to a times x minus 1 squared plus b times with 3x plus 1 times x minus 1 plus c times with 3x plus 1. Then, to find the values of a, b, and c, we have to substitute few values of x. To speed things up, we're going to let x minus 1 equal to 0. So x equal to 1. And we're going to let 3x plus 1 equal to 0. So x equals to negative 1 over 3. So among the x that we're going to use x equals to 1 and x equals to negative 1 over 3. But since we have 3 unknowns, we only have 2x. So we have to choose another x to substitute into the equation. So when x equals to 1, substitute into the equations, we're going to have 15 plus 34 times 1 minus 1 squared equal to a. When we substitute 1 into the equation, we're going to have 0 plus b. When we substitute 1 into the bracket, we're going to have 0 plus c times with 3 times 1 plus 1. So if we simplify, we're going to get 48 on the left hand side, and for the right hand side we're going to have 4c. So c equal to 12. When x equal to negative 1 over 3, substitute into the equation, we're going to get 15 plus 34 times negative 1 over 3 minus negative 1 over 3 squared equal to a times with negative 1 over 3 minus 1 plus b.
when we substitute negative 1 over 3, we're going to get 0. Plus c, when we substitute negative 1 over 3, we're going to get 0. So simplify the equation. We're going to get 32 over 9 on the left hand side. And on the right hand side, we have a times with 16 over 9. So a equal to 2. Next, we have to choose another x to be substituted into the equation. So we choose x equals to 0. When x equals to 0, we're going to get 15 on the left hand side. And on the right hand side, we have to substitute 2 into a times 0 minus 1 squared plus b times 3 times 0 plus 1. So we get 1. 0 minus 1. So we have minus 1 plus c, which is 12, times with 3 times 0, 0 plus 1, so 1. So when we simplify the equation, on the left hand side we have 15, and on the right hand side we have 14 minus b. So b equal to negative 1. Substitute back values of a, b, and c into the equation. So 15 plus 34x minus x squared over 3x plus 1 times x minus 1 squared equal to 2 over 3x plus 1 minus 1 over x minus 1 plus 12 over x minus 1 squared. So that is our final answer.